Warning. The following content may contain elements that are not suitable for some audiences. Viewer discretion is advised.
Good. Oh, hell no. I'm too tired for that. Good morning, everybody. How are we doing today? Good afternoon, good evening, good night, anywhere you are. Welcome to another edition of Whisper Insights. I'm your host, Esteban Kolsky, or I should say today, the tired Esteban Kolsky, who didn't get much sleep the last couple of nights. But we are here because today we have a sensational, outstanding, fantastic, best of, etc., guest. I'm really looking forward to this. I've been looking forward to it for a while. I will let her do her introduction. As you know, I don't like to ruin people's reputations by giving you my summary of what I think they're doing. But this is going to be a really incredible conversation about where we are with AI, but also let's start looking into alternatives. Let's start looking into what are other ways to do AI and all that stuff. Before we get there, let me do a really quick. We have three episodes left this year in the first season. Today we have our surprise guest. We'll introduce herself in a few seconds. Next week, we are talking about a new model for B2B sales. We're talking about changes on the buyer model, changes on the selling model, and how things are actually changing. Then we're going to have a break on the 11th, and then followed by back-to-back two very interesting shows. Dan Miller, whom you know as the great Brent Colson, the bot father, one of the original people who did chatbots, is going to join us to talk about conversational AI and a very interesting concept that he has, which is that AI needs to take a gap year. And then finally, we're going to close the show with the season with a discussion on supply chain with Keith Octan, one of the most interesting and best people to talk about supply chain. That's in the future. This is today. And because I don't want to ruin her reputation, Denise, welcome. Why don't you do your own intro?
Hi, Esteban. How are you doing?
I'm doing great. Thanks for joining me today. How are you doing?
Yeah, thanks for having me. I'm doing great. A little sunburn from the weekend here, but really happy to be here this morning.
Good. It was a beautiful weekend, wasn't it?
It was. It really was. Yeah.
So tell me a little bit about yourself. I mean, I introduce you as a data nerd and a researcher in AI, which is the least destructive way I can think of categorizing what you do. But tell me a little bit, what do you do, what are you doing, where you come from, your background a little bit, anything you want to say. You got the stage is all yours.
Well, I don't like to talk about myself too much, but
but you have to.
So throw it out there. So, right now I'm the founder of AIX Global Media. And for the last couple of years, I've been really focused on education in the space of the spatial web, which is the next evolution of our internet protocol, and then the kind of AI that is empowered through this new structure, which is called active inference AI. And versus AI is kind of leading all of this. So, I usually talk a lot about that as well. But yeah, that's, to me, that's kind of where my focus is.
Yeah. So, let's start with the simple questions. Why do we need a new protocol for the internet? I mean, what's wrong with what we have? It's run I know that I've been doing internet since 1980s. It's been around since ARPA established in the 1960s. What's wrong with what we have, and what do we need instead?
Well, where do I start? The World Wide Web, it's the most unsecured environment to try to run all of these extended reality technologies,
Yeah.
The biggest problems are hacking, tracking, and faking, So, and, right, if you think of our internet, what it is right now, it's a library of websites, web pages, web domains. And as much as we've always wanted the internet to be a decentralized space, it's kind of impossible when all the transactions are taking place under the umbrella of a centralized organization and their web domain. So this new protocol, what it does is it takes us into spatial domains rather than just a library of pages. So that means that every person, place, or thing in any space now becomes a domain. Spaces, nested spaces. It's this nested ecosystem of entities. And, that's going to enable a lot of really cool things. Instead of transactions just taking place under the umbrella of a website domain, now the transactions can take place at every touch point. So it truly is a decentralized space. And that's going to offer a lot more security, a lot more nuanced security than what we experience in the world.
Okay. So go ahead. Yeah.
No. Go.
So then every entity becomes like its own internet, secure internet of sorts. So a library is its own internet, and then through integration protocols, one internet talks to another internet, and we have the broader internet. Something like that, or am I?
Well, so what it's going to enable is kind of digital twins of everything. So, yeah. So, I mean, think about it. So, look at the space that you're in, when, so there's two sides of the protocol, right? There's the protocol itself, hyperspace transaction protocol, and that gives a unique identifier for all things in all spaces, and enables the programming of credentials and just security baked into everything, authorization credentials, identifiers, and then the programming language for the spatial web is hyperspace modeling language. And what that does is that enables context to be programmed about all of the things in the spaces, their interrelationships with each other, different things other than just descriptors, all kinds of parameters. And so then you can actually track them over time, monitor them over time. It's going to enable this contextual world model that we need for AI to be able to actually deal with real-time data. And we can get into that more in a little bit later.
No, I want to get a little clear view for our listeners, and I think I'm trying to see if I can follow this. But what you said is like the traditional HTML, the hypertransfer markup language, versus the spatial web modeling language, and the key term here is the modeling versus the markup. So it's not making nodes on an existing space, but creating a new space that is independent from each other but related to each other in a secure and transactional way. Did I get that right?
Yeah, I mean, and then because of that, you basically have digital twin spaces of everything, right? And so there's a few really cool aspects to that. You can then obviously have this world model that can inform AI of real things, their relationships, and all of the all of the important data around those things and as they change over time. But what it also does is it enables you then to be able to run simulations, because you have this digital twin of, whatever it is. So then we can actually run simulations through the AI to be able to, predict what may happen if we, tweak certain parameters, if we make different choices, whether that's with business, whether that's with, even to the point of things like climate change and all kinds of planetary issues. So
this is part where it gets exciting. Actually, we had a conversation like this a few weeks ago, and I was like totally enthralled in the idea. So I don't think it's highly complex in technical terms, but it's in in imagine if terms, right? This is the part that I'm trying to get to. But so the part that really attracts me to this is the contextuality of it, how to use context. We always say, everybody says, content is king, context is queen, or whatever, vice versa. Pick one, it doesn't matter. But the problem is like in a markup language like we have, there's no context that applies because we have to build the context every time we do a transaction. What you say, and it's in this spatial web markup modeling language, what we have is like each instance, we can create multiple twins, like you said, which is in cloud terms is kind of like an instance of a new cloud, essentially, right? I mean, basically, so we create each element becomes its own instance, and then the metadata and the information that comes with it can be used to create context between 2 or 3 or more instances, or elements colliding with each other. So, for example, to use a term of a library again, each book will be its own term with its own metadata and context and everything. Within the larger model that is a library, within the larger model that will be a city, within the larger model will be, and all these things that can be inherited and distributed and everything. I don't want to get too complicated, but I mean, basically, everything becomes completely independent, but also completely powerful, right?
Yeah. And when you think like, what we expect from future smart cities, right? Just the infrastructure alone and all of the different components of the infrastructure that need to seamlessly work with each other, and also be able to be adaptable with time. Over time. And, this new protocol enables that. The AI that is enabled through the protocol, it does that. It can track these things over time.
So let me try to pull up a little bit. I think we got a little too deep into the guts here, but so where does this protocol come from, and how did we come to create something like this? I mean, what was the original? What's not working, and this is how we fix it. Moment for this.
Well, so the protocol itself. So Versus AI, Dan Mapes and Gabriel Rene are the 2 original founders of Versus, and back in probably 2017-ish. They started Versus, and they knew what they wanted to do. They were observing all of these emerging technologies that, are ready to converge, but the foundation for them to become interoperable was not there. And they knew what they wanted to build as a company, but they also knew, well, this is never going to happen unless our internet evolves. So
right.
We wanted to build the new protocol, so they did, and then they donated it to the public because nobody can own the internet. So it's a public entity. And, they also donated the IP to the IEEE to have the global core standards developed around it. The IEEE, they're the standards body that develops things for like the global standards around Bluetooth or Wi-Fi, or, really any global electronic standard that is going to be used worldwide. So, and the IEEE back in 2020, I believe, they deemed the spatial web protocol a public imperative, which is their highest designation. Wow. And actually, it's now gone to balloting with the IEEE. The final draft was just approved through the working group. I've been a member of the working group for the last couple of years, developing the core standards around this, and it's about to be finalized as here it is. It's a public core standard now. And what they've done is they've built the first platform that's going to be the first public interface to be able to use this new extended part of the internet. Same internet we're using right now. It's just like when we went from TCP/IP, an email into, now we could build websites. It's like, now we can program spaces. And these spaces are now, empowered with AI. So,
that is pretty fucking cool. But so actually, Dan Miller, who's going to be our guest in a couple of weeks, said that he loves the concept of digital twins re-emerging. We know that it's been around for a while, but with a total new and thought-provoking meaning. And actually, what I like is the thought-provoking part, right? This is why you're here. And I know that it's a complex topic, but so far we managed to go from the internet wasn't working. Let's redefine it. Let's actually create a better model of the internet. I mean, when I was doing internet in the 1980s, we used terms like Gopher and Yellow Pages, right? It was basically a whole slew of Sun, NFS, and Novell servers connected to each other where you can go and download documents, right? Then somebody decided, let's make it visual, and we went to the web, and then the web became the piece of crap that it is today. But that is still kind of, for the most part, supports everything. But I like the idea of going into a different thing. And what I like is what you've been saying about how AI applies differently in this, right?
Yeah.
So let's get a little bit deeper into that, because this is the part that really excited me about the conversation we had. It's like, what what the hell is wrong with what we're doing in AI today, other than that it's not AI, but that's a whole different conversation. But what is wrong with AI today?
Well, okay, so the AI that is, that everybody is using and talking about, it's all deep learning, generative AI. And there are some issues with it, as far as, thinking that it could be the AI that will, run our planet.
Well, it's not going to be there that runs our planet. Nobody who's listened to this show, thinks that anymore. So, but
yeah,
it's cute. But it's cute. Yeah.
The thing is these are amazing tools.
Yeah.
Amazing tools. I use them every day. I'm sure most people do now, or at least most people, like, in our realm do now. Because they're amazing tools. But I think what you're going to see with the next era of AI is it's going to become more apparent that these are tools. These aren't really the AI that can run mission critical operations. And the reason why there's a few reasons why, they're not actually doing any thinking. They're not actually making decisions. They're just, it's a huge data center, basically, of tons of data and a bunch of layered neural nets that you put in an output or an input, and it goes through all the data to give you an appropriate output. But it's basically taking the same data that's in it and just regurgitating it, mixing it up, and giving you something that's going to sound appropriate based on what you're seeking from it.
Okay. What's wrong with that?
There's nothing wrong with that. When you're wanting to just write something cool, or, have it code you something, or, make a pretty picture.
Okay.
It's amazing for that.
Yeah.
But it's not going to be able to take real live data and do anything with it. It doesn't have any ability to actually make sense of anything. Now the AI that I've been talking about, and the AI that's going to be enabled, in this next era, is called active inference AI. And Dr. Carl Friston, he is the leading neuroscientist in the world. He's won a bunch of awards on, like, brain mapping, and, he has been developing this active inference methodology for more than 10 years. It's based off of the free energy principle, which is his discovery on how biological systems learn, how neurons learn. And if I were to describe it for, how it works, you basically, if we're just talking about us as humans and how we learn, we're constantly taking in sensory data, from the time we're infants all through our lives. And, we're just taking in sensory information, whether it's, through vision, through taste, through, and we're learning about our environment that way. We're learning about the world and how the world works. We're establishing a world model through those experiences that, give us our understanding of reality. But it's this constant feedback loop of us testing our environment, gathering more evidence, more information to either confirm what we already know, or to update our ideas and our understanding of the world. And that's how biological systems learn. So that's how this AI is going to learn. And the sensory data is real data. It's coming in through IoT sensors and cameras and, different real sensors. And so then you have all this unstructured data that's coming in to the AI, and then the context that's actually programmed into this digital twin system of, spaces and the world. That is those are the clues and the basis for the understanding for these AIs to understand about the world model, the things from wherever its frame of reference is within the network. It understands this basis of evidence of how things work, how they are interoperable with each other, how they relate to each other, how they relate to other things. It gives this basis of real data. And then you have live data that's coming in that's constantly being measured against it, and it helps them to make their decisions and update their understanding as they're going along. So this.
Okay, hold on a second, because there's a lot so far to unwrap. So let's try to put a little bit, in perspective. So, basically, let's say that I'm hungry, right? And I want to eat something.
Yeah.
And I go to a large language model or any other language model that exists today, and I say, "Hey, I'm hungry. What can I eat?" Right? Then what it's going to tell me is going to be, "Oh, here's 5 or 10 different recipes that I collected that they're appropriate for you to eat." And I don't know, eggplant parmesan, pick 10. I don't care, whatever. Right? That's what we get with an LLM. Basically, we get a regurgitation of what exists in the sense of like 10 different things.
Yeah.
Now, what you're saying is, with this new model, I could say I'm hungry, but then the system will say, I mean, there used to be this really stupid meme that everybody was going about how when you call to order a pizza and they tell you that you can only get like gluten-free because your cholesterol is up or whatever. But this is basically what you're saying. Me saying I'm hungry now changes to getting real-time data from my environment and my system that says, okay, you have a package of tofu in your fridge that is going to go bad in 2 days, right? That is good for your health. But whenever you eat, tofu, you don't like to eat it with tomato sauce. So we're actually going to create a mushroom cream sauce to go with the tofu. And, and when you do that, actually, this is going to also create a problem for you tomorrow, because cream is kind of like highly, it's a little bit allergic. It's an allergen to you. So instead of saying, here's 10 recipes, it's like, here's a perfect solution, which we can put together by looking at all these different systems, your refrigerator, your health, your current situation, your body, how it's reacting today. All this in context creates the perfect recipe, which is not actually regurgitated because it was invented, but it's actually offered as a solution in real time from all the input and all the data and everything that we have available. Did I say that right?
Yeah, absolutely. And I mean, another way to kind of look at it too is like an LLM can tell you a great story about New York City, but an active inference agent can tell you what's going on right now anywhere in New York City, so, and that's the difference, you get real understanding, real data, and it's ever changing. And so these agents are adaptable. They're self-organizing, they're adaptable, they're actually able to self-reflect and report on how they're coming to their decisions and their decision-making process. They have a sense of self in the world. It's an embodied AI. And, so this is a whole different level of AI than the deep learning tools. Now, these tools are not going to go away, though. They're going to fold into this network the same way as all other technologies. And that's another aspect of what this spatial web protocol is going to do, because it's not just, enabling AI. Hyperspace modeling language is providing a common language now for all these emerging technologies to be able to be interoperable with each other. So you've got IoT, you've got all Web3 and extended reality technologies, AR, VR, distributed ledger technologies, blockchain, you've got all these technologies now that can become interoperable across this distributed network. And think about this too. As far as the opportunity for what this new expanded network is going to do, because, we know Metcalfe's law and the network effect, right? The value of a network is like the square of, however many users or nodes, right? Yeah. The number of domains for our internet is about to explode in expansion because everything becomes a domain. So our network itself is about to exponentially expand. So when you think of all the technologies that are now going to converge and be able to become interoperable with this common language, and then it's all powered by AI. And these AI agents, this is another big difference between the active inference agents versus deep learning, is these agents, because of the way they learn with this action perception loop, they're able to do that with each other. So they're able to pass messages with each other, share their knowledge, and then you have knowledge within the network, this distributed knowledge among all these agents that can grow the knowledge of the network itself. So it's pretty exciting.
Okay, so let me go through a couple of the comments that we have here, and then we'll go a little deeper into that. Aaron, sure. and I don't know who Aaron is, but he has a really cool.
Oh, I know Aaron.
Okay, I figured that you did because this is more your world than mine. But he's saying that an active inference agent could order your pizza for you, keep in mind your preferences, pay the bill, set up delivery, and I'm even going to assume that if you have the right systems, you won't even know that you ordered a pizza, but it'll be there at the right time for you whenever you need it, without you knowing that you ordered it, right?
Yeah,
something like that.
You just, I want a pizza.
Or you don't even say, you go like, I'm hungry, and like I haven't had pizza in a while, and then like and then your brain says, don't worry, I got you, Bubba. I already ordered your pizza. I'll be here in 5 minutes. It's already paid for. I will use a coupon, right?
Well, yeah, I mean, it's like the ultimate dog bringing you your slippers at the end of the day.
I like that concept. Then Dan says, basically everything becomes a domain, and everyone has his or her own AI agent. And we're not talking about AI agents, and we're going to talk about this more in a second, like we're talking about today, that they're like, determined by a decision tree. We're talking about independent AI agents that basically get created for the specific need and context. And they could be, we're going to talk about this more, but they can be automatically generated as well as generated by anybody within limits and rules and et cetera, right?
Yeah. So, and, one of the things that Versus is doing with their platform, right, is, there's kind of going to be two sides to it. One of them is basically the interface for the public to be able to kind of experience and play within this new extended, reality of our internet. Your interface is going to be an agent. But there's this other side of their platform where anybody can build these intelligent agents as apps, right? Like it's the new software. So, but the difference is you build an app in the Apple App Store, and it's just a siloed application like any other application. But you build one of these active inference apps, and these apps are aware of each other and the network. So the extended capabilities and function of building one of these agents as apps is going to be really incredible. As far as on a personal level, people can do all kinds of things to make their own environment fun and helping them directly, right? Or you can build out something for your business. You can, I think we're going to see something similar. Like when the App Store came out, there were people building things just to solve boredom, and then there were people building for their business. So it's going to be.
So I want to dig a little deeper into that, but I have to acknowledge Alan, who lives in New York, who says he wants to know everything that's going on in New York City right now. So it's actually that would be a really incredible news if you ever think about it. If you go to a city that you don't know anything, and based on your needs and desires, perspectives, preferences, and everything, you get a personalized itinerary of what to do in that exact moment and that exact day in a city. That would be fantastic, right? So
I mean, just think of what this is going to make for travel. Right now. Gosh, you have to book your own flights, and you have to do your own research on the flights, and everything else. And then once you're done with that, then you move on to like, okay, where am I going to stay? And then you got to do your own research, do that, and it's just going from one task to the next. But, one of these agents is going to know all your travel documents, know your travel preferences, what you like, all of that. You can give it instructions of, okay, I need to like say I need to go speak at this event here. I'm going to be in this city. These are the dates I'm willing to travel within. This is the budget I'm willing to stay within. Do it for me. They'll do it. They'll book your travel. They'll suggest things that are going on in the city that you might like, all kinds of things.
So let's get into how you get this done. I mean, Bill Gates wrote in 1999, Business at the Speed of Light. And in Business at the Speed of Light, Bill Gates said in the future, we'll have avatars, which was a term that we used at the time for bots and agents, right? We'll use avatars, communicating with avatars to take care of everything that we need to automatically, right? And it will happen in the background. And for that, we need the internet. That was basically a really bad summary of what's in, for almost a whole chapter in the book, and which is very similar to what you're talking about. It's something that I actually understand and appreciate. So the thing is, there's a couple concerns that I have on this. Let me explain. Number one, if this could be created or generated by anybody, how do you basically prevent malignant actors from creating something that will prejudice? I mean, that would create harm to you. Why can't I say, for example, Denise is allergic to peanuts, so I'm going to actually order a pizza with peanut butter without telling her that she thinks that is what she wanted, that she's going to get delivered, and then she's going to eat it and go into like an anaphylactic shock. I mean, I'm just creating a really bad example here, but I mean, why can I? No, but this is a serious concept. Yeah. Why can a bad actor actually create those things? In today's world, that's possible, but there's no actual execution. In the world that you're talking about, when we let these little guys, and that Bill Gates was talking about, when we let all these little guys roam free, they become independent actors. So how do you actually prevent somebody from creating a malignant actor? How do you prevent security breaches from happening?
Yeah, so the security is baked into the protocol. So the hyperspace transaction protocol, it, permissions then are programmed at every touch point. So, there's a lot of security baked into it, and you can program permissions, you can guardrail data, you can guardrail, any parts of the network that you want to, and require there to be permissions or credentials or anything to be able to access those areas. And you can program it in a very nuanced way. So when you think about the problems that we have right now with the World Wide Web, with hacking and and the capital surveillance, and even the faking, right? So just take the faking, the deep faking right now. There will still be people doing making that type of content, in this new era, but it will be really clear if it's fake or not, because the protocol will will offer proof within it, digital proof of if it came from that person or not. And, the protocol itself, it enables this zero trust architecture. So these agents that are aware of, what's programmed into the spaces and how to navigate through it, they'll be able to have consensus about what's real and what's not, and what's, confirmation of realities, that we don't even have to reveal sensitive information to a third party for there to be the consensus within the network of whether it's real or granted or permissionable or not.
So I'm not going to use bad words like blockchain, but this is basically a distributed ledger of sorts, right? With permissions. Yeah. Okay. Yeah. I don't want to use the word blockchain because it sucks as a technology, but we decided to embrace it. But
distributed ledger technology is extremely secure.
It is, absolutely.
And that's what we want.
Yeah. Blockchain is a really lower level of implementation, but I agree with you. This is what we need. So yeah.
I mean, this is really giving us a truly decentralized internet. And it's a decentralized internet that has security baked in first and foremost. And then it also puts the power back in the hands of the user over our own data, because our data permissions can be either granted or reserved on a very nuanced level. Right now in the World Wide Web, you want to use a website or an app or something, you basically say, yes, you have all my data, or no, and then I can't use your platform. Like
exactly.
it's yes or no, and there's nothing in between. In this new, extended era of our internet, you'll be able to give very nuanced permissions. You'll be able to go to the doctor and say, okay, well, you can have access to this amount of data. You can put a time limit on it. You can, you'll have a lot of control over who has access, how they access it. And then there's even, because of the zero trust architecture, like right now, if you want to go into a bar to drink, you have to show your ID. Your ID has so much sensitive information on it, and you're showing it to a perfect stranger.
You're handing it to a freaking stranger that's going to put it in a machine and scan it, and you don't know what happens to that. That blows my fucking mind how people do that. I don't understand.
Yeah, but we don't have a choice right now, right? But this new era of technology, you won't have to reveal the sensitive data to a third party, because the networked system will be able to make those confirmations for you without any sensitive information having to be revealed. It's much more secure as far as data goes.
So this brings me to a couple other guests I had in the show, right? I mean, we had Doug Searles, and I don't know if you know Doug Searles from the Cultural Manifesto, but Doug spent like years with his wife, with Joy Searles. They were actually creating the concept of like, user control, relationship networks, called VRN, or vendor relationship networks, where like you as the user control what information you give to somebody, and you only enter into a transaction in the event that like, you both agree to what you're going to do with the data, right? This is like, markup level, so it's very like, transactional and needs to be programmed and everything, which I really understand. But like Doug and also another gentleman named Kirk Cameron that was at Microsoft that worked on identity introduced me to the concept of sovereign data, which is like the data is owned by this whole first party, second party, zero party data is bullshit. It's all like, the business perspective of what they can get their hands on. But sovereign data means like, you own your own data and you decide what to do with it in each circumstance.
Yeah.
So what I like about this, if I understand what you're saying, and I am pretty stupid, so if I understand, somebody else will too. But what I like about this is like, you get to decide, what's going to happen to your data in every single instance. And there's no way to like, corrupt that. I cannot create an agent that will take ownership of your data unless you actually allow the data to be accessed by me, right?
Yeah. And, it's funny because people ask me all the time, they're like, well, so then are we still going to be trading our data for certain things? And it's like, well, yeah, but you'll get value for it. Like
and you decide what data.
It'll actually be a value transaction, where you're gonna decide if it's worth it to you or not, and when you want to do it, for what reason, and what gain, but it'll become part of a value transaction rather than just blindly giving it away just to access.
This is the part that excites me, right? Because we talk about a lot of different things. And by the way, there's a great conversation going on the LinkedIn comments between Dan Miller, Aaron. I know. Well, I can put it up there. It's just, they're long statements, but I'll do it in a second. But this is the part that excites me, actually, and I would like to get your take on what they're talking about. But this is the part that excites me personally. So you can actually create a contextual transaction governed by both parties, given specific rules that are unbreakable in a secure environment that changes every single moment depending what's going on. And you can instantiate that a million different ways through digital twins that connect with each other. So you could essentially create a pseudo, quantum computer model of sorts, a quantum analytics, a quantum AI model of sorts, without actually diving into like, quantum computers of happening. I mean, it's not going to happen at the same speed and timeline as a quantum computer calculation, but this is basically what we're talking about here, right? Everything happens at the same time in any way you want, and the alternative, resolutions could be considered to be what's the best and then implemented, right?
Yeah. Well, and one thing that's really interesting about what this is going to enable, as far as this distributed intelligence across the network, these agents are being built by humans.
Yeah.
Because of hyperspace modeling language, it enables a way for us to actually program laws and guidelines into these agents that they will abide by, because they will understand them because of common language. So this is a very controllable AI. It's a governable AI. And what it's going to enable is this preservation of a diversity of intelligences that we have throughout our world. Right now with deep learning, it's like everybody's trying to imagine how are ethics going to work with deep learning, because we have to be able to control the information we're loading into it, and then have somehow remove the biases, get everybody on the same page on a global level, which is impossible.
Eliminate fakes and hallucinations, right?
Yeah, exactly. And it's funny because Gabriel Rene, who's the CEO of Versus, when he was on a panel in Davos at the World Economic Forum, he was describing it as, with deep learning, with these deep learning machine, monolithic AI systems, the only option is to get this average ethics in a blender of the world, right? And nobody wants that, because the only way, like if you think about how human knowledge grows, it depends on the diversity of all different intelligences, experiences. You've got various belief systems and all these socio-cultural differences throughout our world, different governing styles, all of that. You're never going to get a consensus out of that. You're just not, or it'll just become this bland robotic system that we're all living in, which that does not sound good to me. That sounds
well. So you're basically creating a cybernetic version of 1984 versus, or Brazil, versus a real Minority Report element where everything has its own context and everything, and security is important, right? So
so what's beautiful about these active inference agents is that you have humans who are going to be developing the agents, imbuing them with their own intellectual ideas and experience, and all of their knowledge. And so then you have all this huge diversity of these agents coming from whatever their frame of reference is in the world throughout the network. And then they're able to learn from each other, share knowledge with each other, and grow that knowledge. And how do we as a globe, as a planet, deal with all of the diversity of different belief systems, different, governing styles, all of our cultural differences? We come to a consensus of, we have a basic understanding of right and wrong, okay, murder's bad, you're not supposed to steal, you're not, like there's this consensus of basic right and wrong. And then there's this allowance and respect for, differences. And it's through those differences and kind of the pushback of challenging each other that the knowledge actually grows. And that's what this AI enables. So you actually are going to have these autonomous intelligent systems that are able to grow in knowledge in a very similar way to human knowledge.
Yeah. Okay. So let's take a little bit. This is not only exciting, but when we had this conversation, I'm like, this is the shit that we need. I mean, not this stupid LLMs. No, LLMs are cute, and people get amazed that you can ask a question and get an answer. And like you said, we all use them, right? I mean, let's lighten the model a little bit. I mean, I put I've written entire books on ChatGPT by saying I need you to write a book, 12 chapters long. This is the main concept. these are the different chapters. These are the title of the chapters. These are the points that I want to emphasize throughout. And I want this, and I put it in there, and literally spat out a bunch of shit that I put into a Word document, formatted, and I had a 46-page book, which sounds like nothing, but that happened in 35 seconds. And I sent it to somebody, and they said, "Wow, this is a really good writing." And I'm going no, that's fucking regurgitated shit. There's nothing in there that's interesting on you. It's just recreating what's already existed. It doesn't really create AI. It doesn't, to me, AI begins in cognition and ends in wisdom, right? So I think that cognition is what the part that's missing from LLMs, because there's no learning whatsoever being done. It's just regurgitating, and there's no wisdom. There's knowledge created essentially by extricating new models of correlation between concepts and words, right? So this is very interesting. So this conversation, I was going to put the conversation that's going on LinkedIn, but I swear that is so long that would take the rest of the time just to read through it. That's what I'm saying. But we'll put the link in. But I'll capture this and I'll put it in a blog post in my blog, and then we'll publish it so we can read it. But essentially, I mean, Aaron is clearly on your side, and Dan Miller is clearly getting his mind blown exactly by what by what Aaron is saying about how we, so they're going to talk some more good. They're going to DM, and you'll get the lowdown on this later. So we're going to skip that for now because we don't have the time. But let's talk, we got about 10 minutes or so. So let's talk about the final parts of this. I mean, we built a new model that is real-time AI based on cognition and wisdom that could instantiate, infinite number of setups that can be digital twins of the same solution and create answers in real time to things that you don't even know you need, essentially, right? By based on perception, decision, action, basically. I mean,
there's another side of this that's really important as well. Yeah. And it's the fact that because these agents are operating across the network in a distributed manner, they're not tethered to a giant database. All of the processing is at the edge, on the edge devices. So, your phone, your computer, your everything. And so when you talk about energy,
but it doesn't, sorry, go ahead.
So, it's extremely energy efficient compared to the way these gigantic, deep learning systems work, because you query one of those databases and it has to go through all of this data that doesn't even apply to what's being asked or anything. It's just part of how it has to work. So they're extremely, they require a ton of energy for the processing of every query. And that's not even the training of these systems, right? But once they're in use, it's extremely expensive to keep them running because of the processing requirements. It's why there's such a demand for the GPUs to operate them. Now,
so you want to put NVIDIA out of business is what you're talking about now.
Well, but like I said, those tools are not going to go away. We're still going to use them. But when you talk about where AI is going in this evolution into this next era, it's much more energy efficient, because these agents they can make any data smart. They don't require trillions of data points to kind of shuffle through to make their decisions. They're using real data that matters. And so it's extremely energy efficient. And then your edge devices can do the processing. So it distributes the requirement for the energy for processing as well. So,
But you know what drives me crazy, truly drives me crazy, is when people talk about putting LLMs on a phone, right? And they get so excited that you can put a Mistral or even a mixture of experts of sorts, or through diffusion, reduce the size of the LLM. But the part that they don't talk about is each LLM you put in a fucking phone needs to be updated every single time that something happens to the base of knowledge of the LLM, and the model needs to be retrained. And if you're going to do that with what do we have, 6 billion phones in the world or something like that, Can you imagine the time it takes for like one minor, every time that something happens that a model needs to be updated, has to be replicated to like, a billion phones at the same time so they can all make the same decision equally at the same time, blah, blah, blah. There's no fucking way that that's a model that works. The model you're talking about doesn't require a base of knowledge. The base of knowledge is carried within the agent itself, So
exactly. And that's the thing is, that's why I say that, this next era that we're moving into, it's going to really reveal these deep learning tools for what they are. They're tools, you can think of them as the tool and these other AIs as kind of the human, they just they're two completely different use cases for them, right?
yeah.
One of them is for real world use, and to grow knowledge. The other one is just their tools. I wrote an article last year, called The Maker and the Operator. These deep learning tools are the maker, make me this, write me this, code me this, the operator is the one that can actually run hospitals or airports or, things that are real data that, mission critical operations.
Yeah. So let's talk about the last section I want to cover. So my brain can take. I mean, I'm hurting so much right now. I can't even begin to tell you. But let's look at So how does this become practical? What's next, or how do we actually make this go past your writings and the spatial web and all that? How does it become practical in this world?
Well, so. Versus, like I said, they've built the first platform that's going to be the first interface for the public to be able to use this new part of the internet. And so if you go on their website, versus.ai, they have their roadmap there. I believe at the end of June, they are opening up their beta of their Genius platform to the wider developer community. And so, for the next, 5-6 months, it's going to be a lot of developers that are building these agents and, as part of the beta. And then I believe December, January-ish, it's going to open up to the public, where the public is going to be able to access Genius and be able to, start building these intelligent agent apps as well. Now, the thing that I want people to kind of have realistic expectations as far as, from my understanding, how these agents will grow and evolve in intelligence. The first agents that we're making are going to be, probably pretty basic, but then people are going to start to develop more tools. If you think of how the World Wide Web started, you had to know HTML to be able to, build a website. And then, eventually people started building tools like drag and drop tools and things that made it easier for other people to then build the websites. And I have a feeling it's going to be a similar type of a situation, in the sense that, there might be a little bit of a learning curve in the beginning, that gap will close very quickly, because AI, I can only imagine, is going to be doing a lot of the heavy lifting, but the more of these agents that people start to build, the more they're going to be able to learn from each other and grow. And then, it's just going to be this snowball effect within the internet. Similar to, when Apple launched their first iPhone, there were only a handful of apps, and then people started building them like wildfire. And then before we knew it, there were a ton of apps. And, I think we're just going to see something similar like that. I think next year is the year where all of this is going to explode.
Who are going to be the Sherpas for the people on this? I mean, somebody needs to guide somebody on this, right? I mean, you don't just show up at the base of Mount Everest and start walking and get there.
No, true. And that's why I've been doing all of the educating that I've been doing. And, this year I've been hosting a monthly learning lab. That's where I know Aaron from. And, you know, these learning labs are great because every month I'm creating a new kind of educational presentation around, you know, deep diving into different aspects of this technology. And I'm going to continue doing it throughout this year. And I'm, you know, putting courses together around all of this, around the spatial web protocol, you know, to give people some tools to actually wrap their heads around it, gain some deeper understanding so that they can, you know, kind of have a platform to dive off of when they dive into building these on their own.
But it's too much for you only. Are there other people working on
Agreed,
this also?
agreed.
Yeah.
And I know I'm sure I won't be the only one. And
Okay.
you know, one of the things, like I say this a lot to people, is that, you know, you have to think of the opportunity that is coming with all of this, even outside of just building these agents. You know, our entire way of computing is shifting. And so I have, you know, I know several people in different parts of the world right now that they can't wait to see what the tool set's going to look like on Genius to be able to build these agents, because they want to build innovation labs. They want to build an army of developers so that once this hits the public, because anybody who has a presence in the World Wide Web or an app in the App Store is going to want to evolve that presence into this new capacity of our internet. And, you know, big enterprise organizations and businesses, they're not going to do it themselves. They're going to hire somebody to do it. So I know people who can't wait. They're waiting to build these innovation labs to be the ones being hired to, you know, transition all of these entities into this space. That alone is a huge opportunity. There's just so much opportunity. It's like at the beginning of the World Wide Web, but it's like 10x or even more.
Yeah.
It's
where do people find you and your learning labs? I mean, what's the best traditional website to go to?
Yeah, so you can go to my website, my blog, which is deniseholt.us. And, you know, on there, I've got information about the Learning Lab, about joining my Substack. To access the Learning Lab, you just join my Substack and then you can attend them. And the beautiful thing about the Learning Labs is I give the presentation, but then I open it up for like an hour and a half discussion afterwards. So everybody who is on the Zoom can meet each other and start to, like, you know, build this community of finding synergies and, you know, oh, what are you working on? What are you working on? Let's do this, you know, let's plan something.
Are these very nerdy places where people like you get excited about things that most people don't understand, or can we get normal people in there?
So yes, I'm sure everybody there is just as excited, you know, as me. But it's a very diverse crowd of people. It's everything from PhD researchers to tech developers to business advisors to educators. Aaron is an educator. There's all kinds. There's a bunch of investors there. It's a big group of people, and everybody's there because they see this they see it for what it is. And, you know, they're trying to find their mark in it, right? How to make their mark in this next era.
Unfortunately, I'm constrained to 1 hour. I would love to go in depth. I hope that we didn't create a depth of, like, you know, nerding a lot of, like, you know, details that are unnecessary. I think that you did a fantastic job despite my attempts to try to corral you. So I appreciate that. Thank you very much.
Thank you, Esteban.
Thank you very much.
For having me.
It's one of the most interesting conversations, you know, that I had in a very, very long time, and why I want to have you here. We will have you back to talk more, as you know, as they, like, the IEEE approves the concept, the model gets released, you start seeing things in your learning labs that are interesting. I want to close with this quote from Aaron that actually summarizes what he just said in different words, so that we know that it's not just you and me getting excited about this. This, to me, is like it's the best fucking drug in the universe. If I could spend my whole day talking and doing this, I would be so happy. So happy. This is like bringing together things that I've been talking about for like decades. In 1939, the U.S. Navy commissioned a report on distributed work, and that's how all this shit started. 1939. We're almost 100 years from that in thinking about it, and we're finally starting to get a model that goes somewhere, right? So Aaron said, I'm going to close with this, basically said, imagine the new experience of watching the evolution of a new AI species. That scares the hell out of me, but okay. That operates within the world similar to living beings, but at such a higher speed. And exactly, right?
Yeah.
So, I think that we killed it today. I don't think there's anything left to say. So with that, we're going to be going. Thank you everybody. Thank you so much. And we'll get back. Yes, we'll get back. We are out. We are actually back next week and out the week after that. Thank you.